In yesterday's session, we discussed about RAID groups, how RAID 0, RAID 1, RAID 4, RAID 5, RAID 6, nested RAIDs as RAID 10, RAID 01, RAID 50, it works. And we also discussed that you know NetApp. One second, let me open the. Okay, so let me open it here and just one second. Close this thing here. Okay. Anyway, so in NetApp we use three kind of RAIDs, which one is RAID DP, RAID 4, and RAID TEC. Okay, so RAID DP protects against two disk failures. RAID 4 one, it has one fixed parity, so it protects against one disk failure. RAID TEC has three parity, three fixed parity, so it protects against three disk failures. Okay. So now we have already discussed about RAID in last. We have also we have explained what RAID DP is, RAID 4 is, and RAID TEC is. In last class, RAID DP is having two fixed parity. One is diagonal parity, and one is like horizontal parity. So two parity we have. Okay, like that. RAID 4 is having one fixed parity. Okay, so today we'll discuss about RAID penalty. Okay, RAID penalty. This is a question what normally your interview will ask you. Okay, just one second, some sound is coming, so let me pause the video a bit. One second. So basically what happens is when when you're using a storage solution, right? So you have to decide what kind of RAID you're using, and depends on capacity and performance. So your write performance in RAID 4 would be better than RAID DP, and it will be certainly better than RAID T. So it depends on what kind of performance you're looking for. And RAID DP will have more fault tolerance because it can protect you against two disk failures compared to RAID 4. So it depends on what you want. It depends on that. You will have different kind of RAID groups you need to adopt. So in the interview, they will ask you different kind of rates. They will ask you to explain what is rate. They'll ask you to explain what is write penalty. Okay, rate penalty. Okay, right. It's also called as write penalty. Okay, so before going into rate penalty, let me first tell you few things, few basic things. Okay, whenever you are trying to measure the disk performance, we measure it in Iops. Okay, in Iops terms. Iops means what? Input, output per second. Okay, that is IOPS. So one read request means what? One read request means one IO. Okay, one write is another IO. Okay, so the thing is in your disk, right, in your storage system, right, what kind of IO you will have, it depends on your disk rotational speed, which is RPM, rotations per minute, average latency, like how much time it takes for the storage system or the disk to deliver the data to the server, and average seek time, like how much time will uh, the seeker or the head will take time to find out the sector where the data lies in the particular platter, if it's a mechanical disk. Okay, so depends on that, your IOPS will vary. So there is some benchmarks. So let me tell you some benchmarks about some SAS disk. Okay, so if it's a 15K SAS, then the IOPS will be 175. Okay, that will be the IOPS. Okay, if it's a 10K SAS, then the IOPS will be 125. Okay, if it's a 7200, like 7.2K RPM, okay, then the IOPS will be 75. Okay, so like that. Okay, so you have to understand, whenever you are using a single disk, it does not have any redundancy, so we have to use disk in a RAID group. Okay, and we need to understand about rate penalty to understand what will be the Iops that can be supported by a particular rate group. Okay, so let me give you an example of rate 4. Okay, before that I think better to give you an example of rate 1. Okay, so rate 1, it's a mirroring, right? So when you are writing a data, it will be written twice. Okay, so you can check here. So when you are writing data, like the block 1 is coming, then another block 1 is there in another disk. Okay, so the data is duplicated. Okay, so that's why for one write, two writes will take place. So that's the reason you have to write on 2 each disk. So that's the reason the write penalty will be 2 in case of RAID 1. So write penalty of RAID 1 is 2. Okay, now let's go to RAID 5. One second. Now let's go to RAID 5. Let me take a picture here, and this one is a better picture. Okay, you can see that it's a RAID disk is a 3D plus 1P configuration, 3 data disk and 1 parity disk, and the parity is distributed across all the disk in that particular RAID group. Okay, so this is a RAID 5 configuration which protects against one disk failure. Okay, so here what you can see here, RAID 5's write penalty will be better because the data, their distributed parity, or it's laid out in across all the disk in that particular RAID group. Okay, RAID 4, here in RAID 4 what happens, you have only one of the disk will be responsible for all the parity info. So whenever you are writing data, okay, so whenever something write comes, it will write the parity on the single disk. Okay, but in case of RAID 5, you can see here it's spread across all the 4 disks. Okay, you can see here it's spread across all the 4 disks. Okay, so here what in RAID 5 what is happening, it is striping the data, and also it is striping the data means A1, A2, A3, and it is also striping the parity blocks. You can see AP, BP, CP, these are all parity. Okay, it's also okay. So what you're having is, here the write penalty will be 4. The reason being, whenever you are trying to change any data on the disk, first you have to read the data, that's one IO, then you have to read the parity, that's another IO, then you have to write the data, that's third IO, and you have to write the penalty. Okay, to make a write complete. So there are 4 IOs for one operation, one IO. There are 4 one changes in the disk, you are having 4 IOs. Okay, so the write penalty will be 4. Okay, so what about RAID 6? What about RAID 6? So I'm recording this session because last session I forgot to record it. So I thought that I should record this because this will help my students. Because in order to get a job in storage, or in order to do better, you have to have your basics correct. So then only you can move up the ladder. So you need to know the basics, then you can move on to L2, L3. So in storage world, the main storage which is being used widely is NetApp. Then people use Hitachi, EMC, and Pure Storage. Okay, these are the 4 storages that are normally used. And if you know storage, you should know storage automation and cloud automation and VMware automation. And if you know backup, then that's better. That's an additional advantage. So let me go to RAID 6. Okay, in RAID 6 what you can see here, you see an additional parity. Okay, additional distributed parity. Okay, in RAID 6. So it will become similar to RAID 5. The only thing is that you will have here like instead of there it was reading 2 reads, right? So it was reading the data. Okay, in RAID 5 what it was doing, it was reading the data, reading the parity. So here it will read the data and read the parity twice because it's at 2 parities, right? So 3 reads, and it will write the data and write the change data and write the parities, 2 parity twice. So 3 read IOs and 3 write IOs. That means the write penalty would be 6 here. Okay, write penalty will be 6 in case of RAID 6. What about RAID DP? Let me check RAID DP, one second. So this is a RAID DP architecture here. Okay, so in RAID DP it's also having two sets of penalty like RAID 6. So one would assume that the penalty will be 6, but no, the penalty is very low in RAID DP, because NetApp is using because RedDP is normally, it is invented by NetApp. So NetApp is having a unique file system which is like, which is file system layout which is like write anywhere file layout. Okay, so what waffle does is it will basically write the new data to the new location of the disk, and it will move the pointer to the new data. Okay, so it is not doing any reads, it is eliminating the reads that has to be taken place. Okay, so you can see that, you know first, whenever your data is coming, you're writing the data onto storage. So first what will happen, it will write to the NVRAM first, and then it will flush to the disk when NVRAM is half full or every 10 seconds. Okay, so that's why, because the read operations, read IOs are not there, write penalty is quite less in comparison to RAID 6. Okay, and Iops calculation also, I said that in last class. Okay, so suppose you know the application Iops, right, but you have to know the factors that could limit your Iops calculation. Okay, so normally what would be your Iops is, you know that Iops that your RAID group can support. Okay, it would be raw IOPS of a single disk. So what are the disk is there, so that disk. Okay, into what would be your write percentage, okay, so that's you have to do. And you have to divide it by penalty, rate penalty. Okay, plus what you have to do, you have the IOPS of the disk, raw IOPS. Okay, you have to calculate with your read percentage. Okay, you have to multiply read percentage, so this is the thing you get the IOPS. Okay, and suppose you have like 7.2K SAS disk, right, which is having 75 RPM. So in that case, 75 IOPS. So in that case, what will happen? Okay, so how many disks you require? So it will be like RAID IOPS divided by 75. Okay, so that will be the number of disks you require in a RAID group that can support, that it can generate. Okay, that can support. Okay, okay. So this is something that's, we have to make sure, we have to understand about the mechanical disk. This is something, this calculation I have explained this yesterday also. Normally they will ask during the interviews. Okay, so you have to make sure you are you know about this. Okay, sorry, I got cold, I guess. No problem, it does not matter. I never, I always give the training in time, so you don't have to worry about that. You don't have to worry about that. Okay, so yesterday also I talked about a lot of things like for SAN. So what about SAN? I said SAN, there are many protocols like FC, this is fiber channel, then iSCSI, okay, which is called as Internet Small Computers Interface, and then we have FCOE, fiber channel over Ethernet, then we have NVMe OF, okay, 5, so non-volatile memory express over fabric. Okay, so this is for FC. If you are using FC protocol, you need SAN switches. Okay, and you need to use fiber cables to connect your storage with SAN switches, and to connect the HBA of your host with SAN switch. Okay, and for iSCSI you need network switch, so you don't need to do any additional expenses. Okay, fiber channel over Ethernet, that is also Ethernet switches, network switches. Okay, and this is fiber channel. Okay, so this is over fabric, right? So this is all, and again SAN switches. Okay, these are SAN switches. Okay, okay, got it. And in SAN, the basic thing that you have to understand is LUN, which is a logical unit. So it's just the smallest representation of space. Okay, you have to understand that logical unit. Logical unit. Suppose somebody asks you to give 10 GB space, so what do? You create 10 GB LUN and you allocate to the host. Okay, so that's what you do. Okay, and LUN will have different IDs in storage, and when you go to the server like Windows Server, Linux Server, and then you scan it, and then you see LUN ID there. So normally if you are using native multiparting, then you will not see the LUN ID of your storage in visible, in the server. You will see like LUN ID like 012. But if you're using some proprietary multipathing like HTLM PowerPath, HTLM is used for Hitachi, HTLM is for Hitachi, and PowerPath is for EMC. Okay, so in that case you will see the Hitachi is LDAV ID, and this EMC is Symmetrix device ID. Okay, so you'll see that. Okay, so don't worry about it. If it's overwhelming for you, don't worry about it. Okay, it's easy only, nothing is difficult. Okay, so main thing about SAN is you have to have multipathing software installed on your servers. Okay, if you have multipathing software installed on your server, then what will happen? Why do you need this? Let me show you. SAN architecture, I have explained this in quite detail yesterday. Okay, so yeah, this is a good one. This is a good one, but let me just do something else. Is IBM storage selling? Let me just give you a simple thing. Okay, simple representation. Yeah, that would be better, so you can understand. Okay, so in SAN, what you do, you have to have host. You have to use host bus adapter, which is called as HBA, that resides in your server. Okay, so what you normally do, you will have two fabrics. Fabric is collection of switches, so we connect the HBA to the fabric using a fiber cable, and you connect the storage front end port on the fabric with using a fiber cable. So you do the same thing, another HB and another fiber, another fabric, and with another front end port, and you do the zoning. Because of security purposes, you do the zoning so that LUNs, like like data which is meant for one server is not visible to other server. So for that you have to do zoning. We can do direct connections also, like connecting the front end port directly to the HBA. But in that case, what would happen would be only one server would be able to use the front end port. We don't want that. We want to use the front end port by many servers. So that's why we have the switch. So the redundancy here will happen. If the HBA fails, no problem, because the HBA is connected to another fabric and it's connected to the storage. No problem. If the storage fabric fails, no problem, because we still have another storage fabric where through which the server can access the storage. If the storage front end port fails, no problem, because we still have, normally what we'll do in storage, it will be like at least like 2 node cluster. So from each node we'll select one FC port that will zone with the one HBA. So if one of the FC port or the controller fails, no problem, we have the other controller where the FC port is online, so we can use that. So there is redundancy on the controller level, on the front end port level, on the fabric level, on the HBA level. So a lot of redundancy is there. But this like the Iops is going through these multiple paths, right? So workload distribution is happening in round robin process. Means first workload here, IO here, second IO here, and that is managed by your multipathing software on server end. So you have to make sure that you have some multipathing software enabled. It can be native multipathing. Native means it comes with the operating system. For Windows it is, they call it as MPIO. For Linux they call it as multipath. Okay, multipath. Okay, there is some configuration like /etc/multipath.conf. You have to configure that. You have to install the multipath package, and you need to also what you do is you need to start the multipath D service, but you don't need to know that. that work is being cut out by your Linux team, Unix team. Storage admin does not do that, but you have to make sure that your server team is using multipathing software, whether it's native or maybe it's given by EMC or Hitachi or NetApp. So it depends on that, okay? And you always make sure what SAN is. SAN is basically it's a block access, okay? Block level access. SAN means block level access, and NAS is file level access, okay? So what happens is that whenever you are using SAN, you are allocated the storage, external storage to your server, and it's SAN, basically SAN. So what happens, the server will access the external storage as it won't be able to differentiate whether it's a local disk or it's external storage, okay? That's how good it is, SAN. And the performance will be much better. SAN IPC performance will be much better compared to NAS or iSCSI, but it costs money because you need fiber cable, you need SAN switches, okay? And suppose you have some diskless servers, okay? Then what you can do, you want to install the operating system, then you can do boot from SAN. Boot from SAN. For ESX, it call it as, they'll use raw disk mapping, raw device mapping, RDM, okay? So what you do, you allocate the storage to your ESX and you map it as RDM to VM, and when you install the operating system, then what you do, you use the RDM to keep the OS. So it's boot from SAN, okay? But same thing, boot from NAS is not possible. Boot from NAS is not possible, okay? Only boot from SAN is possible, okay? You have to understand that, okay? You have to understand that, okay? Yeah. So this is something there. And for NAS, what protocols they're having? SAN, I said what protocols? NAS is NFS. This is for Unix operating system, and CIFS. This is for Windows operating system, okay? So this is something we have, okay? So I told you this, okay, no problem. So there are many things I will tell you. Don't worry about it. There are many things I'll tell you, like for NAS, when you use NAS, use basically for NFS data store, okay? Or to keep some like have some centralized share, you need some centralized share or something, then you use NAS, okay? And where you use SAN, mainly for database or high-end applications, high-end high in application, okay, use SAN, okay? So that's how it is, okay? So what I taught you yesterday, SAN, NAS, yeah. Tomorrow, the next session, I'll teach you more about the architecture of intelligent storage systems and caches. So I'll teach you these things. I'll teach you about front end port, back end port, cache, how the data flows, everything, okay? So there are a lot of things I'll teach you, okay? So don't worry about it, and I'll go through I will just cover the basics, all the basics very slowly, and then I will also teach you zoning, how switch configuration happens. I will teach you everything, okay? So who are having 5 years experience, less than 5 years experience, I normally recommend them to study L2 because you have to move slowly, and then you can study L3 after you having more than 5 years experience, okay? So okay, so we'll have the next class as we decided at 8 p.m. I think on Thursday. So we'll have the next class. So thank you so much for watching this session. I hope you learn a lot. Okay. And more thing let me add you some more thing. For SAN, what you do, use HBA in server, okay? That you zone with your storage front end port. For NAS, what you do, use NIC card, okay? Use NIC, okay? And normally the NAS architecture, right? I think I will explain here. This is SAN I explained. So NAS architecture, let me explain because I need to tell you more thing. This is your, let me show this is somewhere. Yeah, this is probably, no, I want to show you some better one, okay? Just some better one. I think this is better, yeah. So this is your servers, right? So this is your NAS storage. So what you need to do, you need two, suppose it's a two node cluster, okay, two node NetApp array, okay. So what you do, from each node you select one Ethernet port and you connect to a switch. Other node, you select another Ethernet port and you connect to another switch, okay. Here it's showing only one switch, but normally you will have redundant configurations. Redundant means so you are not having any single point of failure. That means redundancy. Redundancy means not having any single point of failure, okay. So what you're doing, Ethernet switch here, and then other going to Ethernet switch, another switch, okay, and you're connecting the server NIC card to the Ethernet switches. So that's how they do this, okay. And this thing happens over the LAN. So this is your NAS, but because you're using Ethernet switches, so the performance will be much slower compared to SAN, where you use the SAN switches, okay. So you have to understand, you are not going to purchase any additional SAN switches for your NAS environment. You can use the existing Ethernet switches, which is used for some other purpose, okay. Like normally having connecting your own LAN or something, you can use that. Or you can also create, you can also buy some new Ethernet switches for that. So it's on you. But as the traffic goes on through Ethernet, like copper cables, that's so it will be much slower compared to the fiber cables that we use in SAN. You have to understand that. So in SAN we use fiber cables, in NAS we use copper cables, okay. So I will teach you more about these things in upcoming lectures. Don't worry about it. A lot of basics needs to be covered. I'll teach you each and everything. And what I do is, you can join my repeated sessions, okay. So every three, like quarterly, I will have one NetApp batch. So you can repeat the batches without any additional cost. And whenever you get some issues in your project, you can always ping me over the WhatsApp group. It's better you ping me over the WhatsApp group, not one-to-one. The reason being, so if you ping over the WhatsApp group, then other people also learn from your troubleshooting, okay. Because we want to share the knowledge, we want to grow together, okay. So thank you so much for watching this video. We'll meet on Thursday, okay. Thank you so much.